Oh, global cybersecurity. Hello. The only global lady with cybersecurity goodness offering. Is it, Kat? You're writing grade 9 maths tomorrow? Let's see. We can't help you out then. But that's only some of you. You understand? Some of you. That means not all of you. Some of you. Some of you are writing grade 9 maths tomorrow. You're here for support, Miss Global. Oh, nah. Oh, nice. How's varsity treating you, Miss Global? The only lady who's doing varsity goodness. How's that treating you? How's varsity treating you? Okay, so seeing as though Kat is crying, I think Kat has uttered a cry for the grade 9s. You're too stressed. You are too stressed there. Yeah, no. But I'm sure you're having the time of your life. You're living your best life, Maswena. You're living your best life. Everywhere I see you, you're living your best life. Hills Nawunga, I don't do grade 12 this time of the night, so sorry, I will not be doing grade 12. I do grade 12 in the morning, unfortunately. No grade 12. Kat, I think I'm gonna listen to your cry. I'm gonna attend to grade 9s. I haven't done so in a very long time. So let's get some grade 9 up and rolling. I've got a paper here. Alright, term 1 test for grade 9. I think we can go over that, and then maybe certain aspects of what the paper has to cover will also be relevant. So the topics covered here: number systems, factors, multiples, ratio, rate and proportion, finance, integers, exponents, and patterns. This particular paper was out of 50. It was written somewhere in the world. So Kat, you can actually invite other grade 9 learners. Shem, let me do this as well. Let me invite other grade 9 learners. I know that most of the learners here usually are grade 11 and 12 and grade 10, but guys, we haven't done grade 9 in a very long time, and I think my grade 9 learners Okay, so grade 9s, hello to all of you. Yo, grade 9s, I haven't touched grade 9 content in such a long time. Okay, can I just see the entourage of grade 9 learners just saying hello to me, because I haven't seen you guys in a very long time. I haven't had a lesson, I haven't had a session with you like in so long. I don't even know what you guys look like. I was actually happy and proud. There was one learner specifically, I think it was Lesejo. If she's here, that would be great, but if she isn't, then I guess she's not. But like Lesejo has been a stalwart, faithful grade 9 learner that has been with me in my sessions like since last year. Kat, I see, also said that he was here also last year. But Lesejo was actually here during the holidays, my goodness, and like been stalwart, faithful, like nobody's business. I'm so proud. I saw a WhatsApp status of hers actually going to collect some awards, I think, for like some academic performance that was quite phenomenal in the entire grade. And I was so happy. It was such a proud moment for me because I was like, there goes my girl. I was like, yeah, woo. So yeah, it's actually amazing when I see things like that, because it makes me realize that some of you actually take your academics quite seriously. And it's quite impressive when a grade 9 learner takes their academics so seriously. So just keep that up. I'm so proud. I'm so happy. Yeah. Kat, I'm glad you did. That was the whole intention. And I think I gave you guys like most of my attention. Last year, grade 8s and 9s, you guys had all of me. The grade 11s and the grade 12s this year are actually having a little bit more of me than they did last year. And actually, in actual fact, grade 11s, I barely gave them any time. Grade 12s, they just did not have me at all. Grade 10s are also getting a little bit of me. But grade 9s, I haven't had an opportunity to be with you in a long time. So I'm going to do a paper here. Okay, it's a paper written, paper was written by the Chris Hani East District. It's a Department of Education paper. These are the topics that were covered, and these are basically the mark allocated for each, right? Yeah, and it was out of 50. So let's go. Look at this. And Tabby's like, hi, can you please open it? You guys are funny. All right, let's go. Maybe we can do the multiple choice and have people respond. So it says 4 options are given as possible answers to the following questions. Circle the answer for the correct answer. If you made a mistake or change your decision, cross out your response and circle the new letter. So anyways, we are supposed to do what? We need to circle the answer for the correct answer. Yeah. Okay. Schumacher. Yeah, but Schumacher, if you want, you can always, I'm glad that you want to assist me. All right, but please do me this favor. If your platform, or at least let me say your TikTok page, has set up live sessions that you can invite other learners to come and actually view. And I'm sure you can do a phenomenal job in that platform and grow your following there as well. So what kind of a number is square root of 5, guys? Is it 1, A, a natural number, B, a whole number, C, a rational number, D, an irrational number? What do the good people say in the comment section? A, B, C, D. Square root of 5. Which one is it, guys? 10 seconds. 10, 9, 8, 7, 6, 5. Please, the letter, guys. The letter. 4, 3, 2, 1. Square root of 5, people. Square root of 5. Okay. This is grade 9, guys. Grade 9. Okay? Grade 9. So 5 inside the square root is not a perfect square. It's not a perfect square number. So underneath a square root, if it's not a perfect square number, then that number, we refer to it as an irrational number. So it's D that's correct, guys. D. It's not A. Remember, what is a natural number? A natural number is a number that starts at 1, increases by 1, all the way to infinity. So it can't be a natural number, because a natural number starts at 1, increases by 1. So like 1, 2, 3, our counting numbers. Okay. B, a whole number, it's a number that starts at 0, increases by 1, all the way to infinity. Square root of 5 does not fall within that family. a irrational number. Sorry, a rational number. A rational number, guys, is a number that can be written as a fraction where the numerator and the denominator are integers and where the denominator cannot be 0. Okay, this is for grade 9. So therefore, it is not a rational number. Remember, for a rational number, the decimal numbers for a rational number are terminating and recurring. So if you put, for instance, square root of 5 in your calculator and you press SD, you will get a decimal number where the numbers after the comma, they do not repeat and they do not terminate. In other words, they go on forever, but there's no repetition of numbers after the comma. So that's why we refer to this as a irrational number. Guys, the square root of 5 is an irrational number. So this question is calling us to remember our definitions for the different types of numbers. If you're a grade 9 learner and you don't know what a natural number is, a whole number is, a rational number is, and an irrational number is, then you're going to not answer these questions correctly. Okay, let's move on to the next question. The LCM of 96 and 108. The LCM, in other words, the lowest common multiple of 96 and 108. Okay, so what do my beautiful and amazing people say? What is the LCM of 96 and 108? Okay, how do we go about finding the LCM, by the way, guys? Do we know how we go about finding the LCM? There was that way that you guys learned in, in grade 8 and in grade 7, where you would write the multiples of 96 and 108, and then you would catch the first common multiple for both 96 and 108, and you'd regard that as the LCM. Okay, Min is also saying we can use the ladder method. Okay, so let's just see. We can always get our answer. Let's quickly employ, as Mini says, the ladder method. Okay, so 96, all right. If we look at the prime numbers that go into 96, you see, the thing is, we can use the ladder method, or we can now actually just bump up, because we are not in grade 8 anymore, guys. We are in this beautiful grade that we call grade 9, right? What I want to do now is I just want to locate my calculator. Sorry guys, just hang on. I just want to locate my calculator so that you guys can appreciate it. Okay, sorry guys, sorry for that. So just wanted to locate my calculator, because you see, now we are on another level of operation now, because we know what we know. So if you go to your calculator and you say, without using the ladder method, you can say 168. Okay, you then press equal, you press shift, then you press fact, and then you get that, your product of prime factors. You would usually okay, now depending on the type of calculator you have, because you see the type of calculator I have is this one, right? I know that, for instance, the newer version of the Casio calculator, the one that is white, it usually can actually give you the LCM, like from just the calculator. Okay, but remember, for our grade 9 syllabus, we have to actually go the distance of actually writing down the product of prime factors. Okay, so for instance, for 96, the product of prime factors, we have 2 to the power 3 times 3 times 7. Okay, then wait, 96 is equal to, let me just do this again, shift fact. Okay, 96, product of prime factors for 96 is actually 2 to the power 5 times 3. Then the second number that we had there was what? It was 108. Okay, so we go and we try and find the product of prime factors for 98. So we say 108 is equal to, we press equal, we press shift, we press fact, and then we get 2 to the power 2 times 3 to the power 3, 2 to the power 2 times 3 to the power 3. All right, so can you see that? Then for our LCM, we always look at the common base. All right, I don't know why this camera does this. It focuses and it focuses out. So we have 2 to the power 5 and 2 to the power t. So we go for the common base that has the highest exponent. So that means between 2 to the power 5 and 2 to the power 2, we're going to choose 2 to the power 5. Then we multiply. Then we go for 3 and 3. We go for the common base that has the highest exponent. So that means 3 to the power 3. Okay, so those are the two product of prime factors that we write as our LCM. We always choose the common base that has the the highest exponent. 2 to the power 5 would be the one that we choose instead of 2 to the power 2. The common base that has the highest exponent is 3 to the power 3. Now, the product of that, 32 times 27. So we go into the calculator, we go and press 32 times 27. We get that answer, 864. So the LCM is 864. So for people now that are in grade 9, we don't necessarily have to pull out the ladder method. Okay, as you have just seen me demonstrate, you can write down the product of prime factors for your first number, write down the product of prime factors from your second number, and then you know the LCM, you always go for the common base that has the highest exponent for the numbers that you have listed. So for 2 to the power 5 and 2 to the power 2, you go for 2 to the power 5. For 3 and 3 to the power 3, you go for 3 to the power 3. Then you multiply 2 to the power 5 and 3 to the power 3, which gives you 32 plus times 27, which is 864. So if we go to our options, what did they say? The LCM of 96 and 108. Is it A, 168, B, 2, C, 864, D, 96? So our answer obviously then is C. Okay. Yeah, it's pure maths, guys, grade 9 specifically. So obviously we know that the grade 9 maths, we're still mixing it up a little bit there because our grade 9 mathematics is still there, a mix up of both mathematics, pure maths, and our maths lit. Okay, so we are still obviously still trying to find our feet as the grade 9 learners. Let's go to 1.3. Here's another question. A car travels 180 kilometers in 2 hours on a straight road. Okay, now it says how far can the car travel in 210 minutes at the same speed? Let's reread this again. A car travels how many kilometers? 180 kilometers in how long? In 2. Can the car travel in how long? In 210 minutes at the very same speed. Now if you look at this question, there may be two things that are coming to your mind. Maybe you may be looking at the fact that you are comparing two quantities, all right? And maybe you might want to set up a table which will then help you to be able to solve for what is missing. Because you can see a car is traveling 180 kilometers in how much? In 2 hours on a straight road. Then the question is asked, how far can the car travel in 210 meters at the same speed? Okay, so what's coming to my mind is this beautiful Mr. DST. That's what's coming to my mind. So what I want to then do from DST is calculate what? What am I given? I'm given the distance that the car travels in 2 hours. So what I can do is calculate the speed of this car. First and foremost, calculate the speed of the car. Then after that, I can actually utilize that speed with the number of minutes that I have and calculate how far is this car actually traveling with that speed. So let's start here. For speed, we know the formula is equal to d over t. S is equal to d over t. So we substitute. In the place of d, what was the distance? 180 kilometers. What was the time? 2 hours. What's 180 divided by 2? We get 90 kilometers per hour. We are not done. We know that this is the speed that this car is traveling in. So they are asking us, how far can the car travel in 210 minutes at the same speed? So we look at these 90 kilometers per hour. Now we are being asked, how far can the car travel? So in other words, we are wanting to find distance. When the speed of the car is 90 kilometers per hour, as we had calculated it, and we are given what time? The time is 210 minutes. But what we want to do is we don't want our time to be in minutes. We want to convert minutes to become hours. Now, how many hours, or let me say, how many minutes are there in 1 hour? Okay, I'm sure you guys know. How many minutes are there in 1 hour? There are 60 minutes, right? So here, what we are being asked here is we want to convert first the minutes to become hours. So what we are going to do is we are going to take the 210 minutes and we are going to divide by 60 minutes so that we can get how many hours there are in 210 minutes. So I'm going to come to my calculator, take 210, divide by 60 minutes. 210 divided by 60, what do I get? The calculator, guys, gives me 3,5. And I'm just going to work with 3,5 because I want my answer in hours. Or I want to be able to calculate my distance having kilometers per hour and hours. I want these to speak to each other, because if I have kilometers per hour as my speed, it is not going to help me to keep the time being in minutes. So I have to convert the minutes to become what? Hours, by dividing the minutes that I've been given with 60 minutes, because I know there are how many minutes in 1 hour? There are 60 minutes. So I take 210 minutes, divide by 60, I get 3,5 hours. Then what do I want to calculate? I want to calculate the time. So I go back to DST. When I want to calculate time, what is the formula for time? Time is equal to D over S, distance over speed. So what is the distance? Distance is, we're wanting to calculate the distance. We don't want to calculate the time. Look at me getting all excited for nothing. Okay, I want to calculate distance, not time. So let's go back to our formula. Distance is equal to S next to T, S and T. So that means S times T. So distance is equal to speed times time. We want distance. Ne? So let's rewrite our formula. Distance is equal to speed times time. So the speed, what is the speed? It is 90 kilometers per hour. What is the time? The time we calculated, it's 3,5. Then all we do is we use our calculator. We say 90 times 3,5 equal 315. 315 what? Kilometers. 315 what? Kilometers. Because 90 times 3,5 gives me 315 kilometers. That is the distance, guys. Not hours, guys. distance. Remember that what did they want? They said how far can the car travel in 210 minutes at the same speed. Okay, so now we have our options. We either choose option A, 630 kilometers, option B, 25.7 kilometers, option C, 102.9 kilometers, option D, 315. So obviously our answer will be what? Will be D. Alright? Yeah. Let me just relook at this question one more time so that you guys can understand. Maybe I lost some of you. A car travels at 180 kilometers in 2 hours. So it's very good sometimes to note what we have. Car travels in 180 kilometers per hour. What's that? This is distance. I put the D on top of the 180 kilometers. In what? In 2 hours. Okay? In 2 hours. 2 hours is time. On a straight road. Okay? Does that make sense? On a straight road. Now they say, how far can the car travel in 210 minutes? So we are also given time here, but it's not in hours, it's in minutes. How far can the car travel in 210 minutes at the same speed? We don't know what this speed is. So we know that the car traveled 180 kilometers in 2 hours. We can calculate this speed by using the given distance and the time. And we can know what this speed is. So that's why we said we are going to use the DST formula that we know, right? We are going to then calculate the speed first. And we are going to say S is equal to, if you see this is S, that means this is speed. To calculate the speed, we are going to say distance over time. So there it is. S is equal to distance over time. Then we substitute in the place of distance, we have 180 kilometers. There it is. In the place of time, we calculate 2 hours. We substitute 2 hours. Then you say 180 divided by 2 gives us 90 kilometers per hour. This is this speed that this car is supposedly traveling with. Because they said a car travels 180 kilometers in 2 hours on a straight road. Now they are asking us, how far can the car travel in 210 minutes? At the same speed. Now you ask yourself, which speed are they talking about? They are talking about the speed at which the car was traveling in to begin with. So now we are being asked, how far can this car travel in 210 minutes if it's traveling at the same speed? So that is why we first started by calculating the speed. Okay. S is equal to 90 kilometers per hour. This is the speed of the car. So by the time now we want to calculate how far can the car travel in 210 minutes, remember it is still traveling at the same speed of 90 kilometers per hour. So what do? We collect the information for this part where we are supposed to calculate how far can the car travel in 210 minutes. What do we want? We want the distance. Because we are asking how far can the car travel. What do we have? We have the speed of the car because it is the same speed that this car was traveling in to begin with, which we calculated and we got it. It's 90 kilometers per hour. So we have speed. Then time. Time we are given in 210 minutes. But is it okay to just leave this time as 210 minutes? No, we have to convert these minutes to become hours. Why are we converting minutes to hours? It is because minutes to hours. It is because, guys, when we are working with kilometers and hours, it's only then appropriate that we convert minutes to become hours. So we go and we write down time is 200 minutes to hours. We know that there are 60 minutes in a single hour. So we take 210, we divide by 260 minutes, and that gives us 3,5 in our calculator, which we can then say it is 3,5 what? Hours. 3,5 hours. Now we have all the information that we need. Speed is in 90 kilometers per hour. Time is in hours. Okay, now we can calculate the distance. How far can the car travel in these amount of minutes, which means 3,5 hours. So we want D. If we want D, it means we are calculating distance. We have S and T, so we use the formula. If we go back to this triangle of ours, distance is equal to speed times time. So it is. Distance is equal to S times T. We substitute in the place of S, speed, 90 kilometers per hour. We substitute in the place of T, 3,5 hours. What's 90 times 3,5? We use our beautiful calculator. We punch it in. We get 315. And remember, this here is 315 what? Kilometers. So if we go to our options, they said A, 630 kilometers, B, 25,7 kilometers, C, 102,9 kilometers, D, 315. This definitely agrees with our option, 315 kilometers. So we circle D as our option. Okay, let's move on. 1.4. E brackets minus small brackets minus 3 plus 7, another bracket, closed bracket, minus brackets minus 4, close the bracket, times 2. Now they are asking the value of this is equal to what? Question mark. A, 50, B, 46, C, negative 40, D, negative 34. So the question is, what is the value of this expression? Now for those that are looking at this, remember, if you were given this question as a question where you were supposed to show your steps of how you got the answer, you would have to show the steps applying what to it? Applying bad mess. What is bad mess, guys? You apply brackets. You first look at the brackets. E means exponents, D means division, M means multiplication, A means addition, and S means subtraction. So if you look at 3 is outside the bracket. Inside the bracket, you can see there's a minus. There is another minus inside this small bracket, 3 plus 17. Close the bracket, and then you have this bigger bracket that's there. So 3 needs to wait so that things inside the bracket can happen. Okay, meaning it is BODMAS, but I usually say to my learners that E stands for exponents. It means all roots and exponents are accommodated by E. All right, so yeah, BODMAS, BADMAS, I tend to speak more about brackets, exponents, division, multiplication, addition, and subtraction. That's fine if you are saying BODMAS, but just as long as you know that if in a particular mathematical expression you have exponents there, you must make sure that after looking at brackets, you must look at exponents, they follow, and then after that, division, multiplication, addition, and subtraction. So for this question, you may as well take your calculator, put in the values. You should be able to get the answer, whether it's A, B, C, or D. But remember, if this was a question whereby we have to show our steps, then it's very important to note what you would do. So this 3 that's outside would stay outside for the meantime. Then we would take care of what's inside the bracket. So in other words, the minus sign as well will stop, and we'll take care what's inside the smaller manana bracket. There we have minus 3 plus 17. Now what's minus 3 plus 17? Minus 3 plus 17, guys, gives us 14. All right. You see that minus sign that was there? It's still there. Then we follow it with minus into minus 4 times 2. Okay, then we go a step further. We take this negative sign, we multiply it by 14. That gives us 3 minus 14. Now this negative times the negative will give us a what? A positive 4 times 2. To finish off, what's 3 times negative 14? Because this is 3, this is a bracket. 3 times negative 14 gives us, remember brackets mean multiply in mathematics. What's 3 times negative 14? 3 times negative 14, guys, gives us, hoping people can really help me, positive times the negative obviously is negative. What's 3 times 14? It's negative 42. What's 4 times 2? It's 8. And then you have negative 42 minus 8, which should give you what? A negative 34. And guys, if you look at your options, A, B, C, D, I've basically shown you step by step how to arrive at the answer, applying my understanding of BODMAS. Took care of what's inside the bracket first. Inside the smaller nyana bracket, I got 14, applied the negative times the positive, get negative 14 inside the big bracket. Then here I have a negative 4 in brackets, I have a times 2. That means the negative times the negative gives me a positive 4, and then a positive 4 times 2 gives me positive 8. Minus 42 plus 8, guys, gives me negative 34, and that basically means my option that I am choosing is option number D. Okay. All right, and that's it. Nothing much to that. Let's move on to 1.5. Simplify 4a to the power 12 divided by 4a to the power 3. This here we have what topic? We have the topic of exponents, simplifying exponents. 4a to the power 12 divided by 4a to the power 3. Grade 9. Those who are coming in. 4a to the power 12 divided by 4a to the power 3. Are you working it out on the side? Do you know which option is correct? A, B, C, D. Let's see if people are really actually doing their own working out on the side. Let me know as soon as you get the answer which option is correct. Is it A to the power 4, B, A to the power 9, C, A to the power 15, D, A to the power 36. All right. Yeah. Remember, 4a to the power 12 is divided by 4a to the power 3. Please be very careful with that. 4a to the power 12 is divided by 4a to the power 3. Most people in the comment section are saying option B. Now let's check this out. Let's see if people really understand this. 4a to the power 12 divided by 4a to the power 3. Remember, when we are dividing, all right, we must take note of the following. S, N, L. What do we mean by S? S means we first take care of the division of the signs. N, we take care of the division of the numbers. L, we then take care last and foremost of the division of the letters. Okay, or the variables if you want to call them that way. So we'll start here. A positive divided by a positive gives us a positive answer. Okay, so if you are spot on. So that means our letter is going to be, our sign is going to be positive. The answer is going to be positive. We move on to the number. What's 4 divided by 4? That is actually equal to 1. Okay, so our number is 1. Then we look at the letter. A to the power 12 divided by a to the power 3. There's a law of exponents that says when we are dividing the same base, a and a are the same base, we keep the base, we subtract the exponents. Keep the base, subtract the exponents, because there's a division of same base letters. Okay, so we must not forget that rule. So our answer is a to the power a to the power 12 minus 3, a to the power 9. Therefore, our option that we choose here is option number B. So those who said option number B were 100% spot on. That when we are dividing, we keep the base for the letters if they are the same. We subtract the exponents. Literally, you could even think about it this way, even with the 4 and the 4. You would keep the base 4, you would subtract 1 minus 1. What does that give you? 4 to the power 0 and 4 to the power 0. We know that any base raised to the power 0 for our number 4 will give us what? 1. Okay? I don't know why this is blurry again. Yeah. Okay, so please, grade 9s, may take note of these little rules. Okay, then with A, we know it would be 12 minus 3. So A to the power 12 minus 3 gives us A to the power 9. Okay, so yes, guys, this is very, very important that when we are dividing same bases, we must keep the base and we subtract the exponents. Let's not forget that. Okay, very, very important. So option B is 100% spot on. So that is why at the end of the day, that 1, remember, that 1, okay, we can actually write A to the power 9. The 1 is there, even if we don't see it, it's there. Okay. Schumacher, you guys in grade 9 and 8, remember there's a rule for same bases. All right, the laws that you do have to do with same bases. When you are multiplying same bases, if you are multiplying same bases, you keep the base, you subtract the exponents. So those laws apply for same bases. Okay, remember, if you have different bases, like for instance A to the power m times B to the power n, these bases are different. Okay, right? A to the power m times B to the power n is equal to A to the power m times B to the power n. Okay, yeah, because multiply will combine different bases, and that's it. But you retain your exponents as they are. Okay, because these laws, they only apply for when the bases are the same. So adding the exponents applies when you are having same bases and you are multiplying the same base. And then subtraction of exponents has to do with when you are dividing same bases. All right, then you subtract the exponents. Okay, let's move on to the next question. Consider the pattern 5, 8, 12, 17. They're asking the next term in this pattern will be. Guys, what will be the next term in this pattern? What will be the next term in the pattern? 5, 8, 12, 17. The next term in this pattern will it be A, 19, be A, 19, B, 21, C, 23, D, 20. Which one will it be? Okay, Cat says 23. Can you guys see what's happening with this pattern, by the way? Okay, I'm just gonna come back just now. Do you guys see what's happening with this pattern? All right, this is a unique pattern because from 5 to 8 you should be observing something that's happening. What did they do from 5 to 8? They added 3. From 8 to 12 they added 4. From 12 to 17 they added 5. So what are you expecting will happen from 17 to the next term? They added 3, they added 4, they added 5. So what are they going to do to the last term? They're going to add 6. Yes, so we are adding consecutive numbers to the original pattern. Adding consecutive numbers starting at 3. That's what's important here. If you were to describe in words what's happening here, we add the consecutive natural number starting at 3, which is 100% spot on when you consider it in that light. Add the consecutive natural number starting from 3. So we're adding 3, adding 4, adding 5. And the reason why we say the answer here is 23 is because we can clearly see that obviously this addition of consecutive numbers starting from 3 is something adding the next. Remember guys that grade 9, you guys at the end of the year, grade 9, you write a GEC paper. That GEC paper consists in the majority of multiple choice questions. So I'm sure you guys may ask yourselves the question, why did it take so long for Munir to just answer 6 marks worth of questions? Okay, it's because we had to apply some thought. We didn't just go and circle what seems to be the right option. We looked at the question, we read it. What kind of a number is the square root of 5? I first looked at the definition of the 4 different numbers just to make sure that we can all remember these numbers and what they mean. And we concluded that the option here is D. The LCM of 96 and 108, we used our calculator, we wrote down the prime factors of 96. We wrote down the prime factors of 108. Yes or no, I'm going to upload it on the YouTube channel after I'm done. And then what we did is we identified the common base with the highest exponent so that the product of that would be equal to our C is the correct option. 1.3, we looked at this question, we read it, we found out there is a certain car, it travels at a certain distance, it's traveled a certain distance in a certain number of hours on a straight road, and we are asked how far can that same car travel in 220 minutes if it's traveling at the same speed. So we had to first calculate the speed of the car so that we can know that if we're looking at the speed of that car together with how long it took for the car to travel, then we can have an idea in finding out how far, meaning what is the distance that that car traveled in that speed. And we saw that we have to make sure that our units that we are using are very much appropriate, because we can't have minutes pitching in a calculation. We must convert those minutes into hours, and that's why at the end of the day we got an answer where we supported that D is our answer. 1.4 did not just come simply by us choosing an option that we wanted. We worked this out applying bed maths, and then last but not least, and then that's how we got D, which is negative 34. And last but not least, simplifying this, we applied our laws of exponents. We remembered and recalled the laws of exponents for division, that when we are dividing same bases, we keep the base and we subtract the exponents so that we can be able to get that answer, which we said is option B. So those who are like asking, what is a GEC paper? Guys, it is that paper that you guys write at the end of the year. All right? Because our Department of Basic Education has introduced GEC, right, so that they can basically make it a paper that is standardized for all learners, that is at a certain level. And yes, those papers do present a level of difficulty, right? But what I'll be doing in this channel is that throughout this year, as I go on doing lessons, doing revision sessions, I will utilize those GEC exams. So when I have lessons for the grade 9s, you will definitely get a taste of those GEC type questions so that you guys can become familiar, so that by the time you guys write your final exam end of this year as a grade 9 learner, you will be equipped to be able to do extremely well. Okay, yeah, so that's very important, because remember, even your teachers at school, when they see how well you did in that GEC paper, let's say for mathematics, it will basically judge. It will be sort of like an indication to them of whether you are eligible to do mathematics, pure maths at your school. All right. So let's move on now, guys. I think we at least understand. You saw most, even with the pattern here, we saw that this has it is progressing using consecutive numbers starting at 3, and basically 3 plus 4 plus 5 plus 6, which means our next number will be 23. Let's go. Question 2. Number systems, factors, and multiples. We are asked, classify the following numbers as either rational or irrational. Here's the first one. 4.5. Is this a rational number or an irrational number? We just need to write that. Rational or irrational. So 4.5, guys, this is a mixed number. A mixed number, okay, is this a rational number or an irrational number? We know that we can convert a mixed number to a fraction, right? We say 2 times 4 is 8, and then we say 8 plus 1 is 9. So this is basically 9 over 2. 9 over 2, guys, is it a rational number or is it irrational? Yes, Wandile. Very good, Wandile. No, Wandile. That's not good at all, actually. 9 over 2, Wandile. You're saying it's irrational. Okay, Kanya is saying rational. What does everybody else say? Classify the following numbers as rational or irrational. Guys, do we know what a rational number is? A rational number. I'm going to write a rational number. Right? So, for example, 0 is an integer, 1 is an integer, 2 is an integer, 3 is an integer. You go back in your negative numbers, -1, -2, -3. Those are rational numbers. So 9 denominator, 2 are integers. We call this a rational number. So the answer is rational. Please, people, you. And you know what's even beautiful here? You can even confirm there are 2 forms of the decimal for rational numbers. Rational numbers can either be terminating, in other words, after the comma, you have 1 number or 2 numbers or 3 numbers, but they come to a stop. They don't go on forever. This is called a terminating decimal. Or we can have a recurring decimal. In other words, when there's a repetition of a number or 2 numbers or 3 numbers forever without any end. That is the type of decimals you get for rational numbers. So 9 over 2 is a terminating decimal. It's furthermore a rational number because of that. Square root of 17, guys. Irrational number. Square root of 17. What do y'all say? What do y'all have to say? Square root of 17. That's funny. Look at what I love this thing. Lay is saying that she told her mother that she's studying, but I'm actually watching why? Because 17 is not a perfect square number. Okay, when you have a perfect square number inside a square root, then you would say it's rational. But 17 is not a perfect square number and it's inside a square root, so we call that an irrational number. Irrational numbers are non-terminating and non-recurring. Look at the recurring, meaning there's no repetition. 5 times 7. We are done, guys. We've got 1 mark, 1 mark, 1 mark. The HCF of 135, 225, 315. Haibo, 135, oh, there's 135. 225, there's 225. 315, there's 315. What do they want now? The highest common factor. So now I'm going to use my prime bases there. What am I going to choose? I'm going to now choose the product of the common bases with the lowest exponent. So let's go. 3, 3, 3. Which one is the base that has the lowest exponent? We can see that 3 squared is there. Okay. Then last but not least, 5, 5, 5. Which one has the common base? Common base is 5, which has the lowest exponent. Okay. And then 7 is not a common base, so I'm not going to include the 7 in the mix. So 3, 3, 3 common. So I choose 3 to the what? 3 to the power 2, because it is the one that has the lowest exponent. 3 to the power 2 has the lowest exponent. 5, 5, 5, common for all three. So now I choose the common base that has the lowest exponent, and it is this 5. 5 has what at the top there? It has an exponent that is 1. We can't see it, but it's there. Is 7 common? No, it's not. So we don't include 7 for our highest common factor. Guys, we do not include 7 for our highest common factor. So therefore, the highest common factor is equal to, what's 3 squared? 9 times 5. What's 9 times 5? It's 45. So this is the highest common factor, guys. Okay, this is the highest common factor. So let's go back. See, people are saying product of the prime factors. One more time. 135. Go to your calculator. You go press 1, 3, 5. Then you press equal. Then you press shift. Then you press fact. There we have it. The next number, 225. Same thing. Go to 225. Press equal. Press shift. Press fact. There we have it. 3 squared times 5 squared. 3 squared times 5 squared. Do you see that? Let's go press 315 equal to shift fact. 3 squared times 5 times 7. 3 squared times 5 times 7. Very good, Luca Mac. Thank you so much for writing that down. So you write down the numerical value amount. You press equal. You press shift. You press fact. That's how you get the product of prime factors, guys. Because this is saying write down the following numbers as products of their prime factors. So this here is saying goodbye to the ladder method. Hello, calculator. Goodbye, ladder method. Hello to calculator. Bye-bye, ladder method. Hello to calculator. Goodbye, ladder method. Hello. Ladder method. Hello to calculator. And it means we don't waste any time. We get straight to the point. You see? Alright? So in E can be written down, but then I must choose the one that has the lowest exponent. Which one is the lowest exponent? It's 3 to the power 2. Here it is. So 3 is done. Now I move on. 5. Is it a common base? 5 is here, 5 is here, 5 is here. 5 is common. But then I choose the base with the lowest exponent. Which one has the lowest exponent? It is this one, 5 to the power 1. There he is. Go on to the next base. Base 7. Is it common for everyone? No. No, not common for everyone. So therefore we don't write 7 as a product of these identified factors. Are you with me? So then we take 3 squared, it's 9. 9 times 5 is 45. The highest common factor, guys, of 135, 225, and 315 is 45. Done. Now I see there's people that are saying, sir, can you do the LCM? LCM, we would obviously get the product of the prime factors for all 3 of these. All right, we would start there, of course. What's the product of prime factors of 135? There we have them. We would use that 135 is equal to shift fact, get that, and get that. Then, when you are dealing with the LCM, you must choose the common exponent. So this time we are interested in the common base with the highest exponent. And you know what else is beautiful? It doesn't have to be common for everyone. Unlike the HCF, it doesn't have to be common for everyone. Okay? So that is the difference with the LCM. For the LCM, I usually say to my learners, we even take the leftovers, because L stands for leftovers are also taken by the LCM. So let's check this out. Look at this. 3 to the power 3, 3 to the power 2, 3 to the power 2. Is it common? Yes. Not necessarily common for everyone, but it's common because it's available for all three. Then we choose the base that has the highest exponent. So we would write 3 to the power 3 because the base with the highest exponent is 3 to the power 3. Are you with me? That means I'm done with 3. I move on to the next base. 5, 5, 5. Common. Go for the base that has the highest exponent. So now I go times 5 to the power 2. I'm done with 5. Move on to the next base. 7. Is it common? No, it's not common for everyone, but do you know what? It's a leftover. Okay, let's say there was another 7 here. Let's say it was 7 squared. Okay, then between these two, I would go for the common base with the highest exponent. Are you with me? And then that would be done for 7. But because here 7 is alone, guys, 7 is alone, we are going to write 7 as that leftover. Are you with me? Because 7 is alone. Then we can use our 27 times 25 times 7. A huge number, this one. So let's use our calculator. We get an answer of 4,725. So my learners who are here were asking me, what about the LCM? Please, please, please notice the difference. When we are dealing with the LCM, we go for the common base with the highest exponent. Lowest common multiple, but we go for the common base with the highest exponent. And we don't forget the leftovers. For highest common factor, we choose the common base with the lowest exponent. But we have a clear obsession with highest common factor of making sure we go for those that are common for everything. Those who are not common for everything, we don't even take a look at them. We don't even get our eyes in their direction. So that's why 3 squared and 5 were the only ones that qualified. They were the ones that were common for everyone and had the lowest exponent. I multiply them, I get the highest common factor. Difficult? Guys, surely I hope you got it. Let's move. Other things are calling us. Ratio, rate, and proportion. Ratio, rate, and proportion, my grade 9s. Two numbers are in the ratio 3:5. If the smaller number is 12, what is the greatest number? I repeat, two numbers are in the ratio 3:5. 3:5. 3:5. If the smaller number, that means the smaller number is aligned with the smaller number in the ratio, then the question is, what is the greatest number? So the greatest number is the one we are looking for here. Now the question is, what happened to this 3 for us to get 12? That means we took the 3 and we multiplied by 4. So for a ratio, whatever you do to one numerical value of the ratio, it means you do the same thing to the other numerical value of the ratio. If 3 times 4 is the one that gave me 12, how do I find the other number here? I'm going to say 5 times 4, so that would give 4. So that would give me what? 20. What is the greatest number? It is 20. Done. So this is simplification of ratio. You know what's interesting is that they have actually asked a question that they usually ask in reverse. Usually you get given a certain ratio and they say simplify the ratio. That's what they usually do. So you take this 12 and this 20, you would find the highest common factor. Then you divide by the first number and the second number, you would get the simplified ratio. But this time round, they give us a particular ratio and they are saying if the small number is 12 and what is the greater number? So obviously we are going to align the smallest number with the smallest number in the ratio. Okay, because something happened to that number in order for us to get 3. Then we are going to try and find what is missing. Okay, so therefore that would mean, what did we do to the 3 to get 12? We multiplied by 4. So what would we then do as well to the 5? We'd multiply by 4. Okay, that's fine as well. Okay, so basically that's why we say the greater number. You would actually conclude and say the greater number, answer their question, is what? Is 20. Okay, and I mean, whoever's marking my paper is going to see that, oh, I saw that 3 times 4 is the one that gives me 12. 5 times what? 5 times 4 then, because I'm going to, if I multiply by 4, I have to do multiplication by 4 here. That means that other number is 20. Okay, let's look at the next question. We are asked here, if 3 kgs of potato cost 24 rand, how much will 7 kgs cost? Now this is a typical proportion question. 3 kgs of potato cost 24 rand. How much will 7 kgs cost? So I'm going to say here potato and cost. I hope you understand. My potatoes, I have 3 kg of them. The cost is 24 rand. 7 kgs on the other hand, I don't know what the cost is. So this is a typical table that I would set up for my information. Potatoes, then I know this is actually cost. When it was, I didn't know the amount, I had 7 kg potatoes, but then of course if it's 24 rand, it means I'm talking about 3 kgs of potato. Now I want to look at these quantities a bit more separately. Yes, Esona. Esona, it means you were here, man. You were here. Esona was so here. Alright? X to the top on the left. Yeah, when you still remember the stuff. I love it. I love it for you. Okay? This one quantity, okay? I'm sure you guys can see. If 24 kgs, if 3 kgs cost 24 rand, what are you expecting with 7 kgs? Is it going to cost more? Or is it going to cost less? Obviously, you are expecting more, right? More. So with an increase here this side, you are also expecting an increase this side, which means increase. What does that tell you? The quantity of cost increases, the quantity of potato kgs, it also increases. That means this is direct proportion. So if I was asked, for instance, what sort of proportion is this? I would be able to clearly say that this is a direct proportion. So I set up an equation. The ratio, what does it say? For direct proportion, okay, the comparison between the two quantities, is going to form a particular ratio. Okay, yeah, a particular ratio. So I'm going to say x over 7 kgs is equal to 24 rand over 3 kgs. Then I'm going to cross multiply. So that means x is equal to, I cross multiply the 7 kg, I have 24 times 7 over 3. You grab your calculator, you say 24 times 7, you get 168, divide by 3, you get 56. So it's 56 rand, guys, not 54, 56. Okay, 56, 56, 56. Okay. Yeah, so we use our knowledge of direct proportion because as one quantity increases, the other one also increases. So what do we know about the ratio between the two quantities is constant for direct proportion. The ratio between the two quantities will remain constant. Okay, yeah. So that's why we say x over 7 kg, because the ratio between the two quantities is constant. In other words, the ratio for this is equal to the ratio of that. That's why we say the ratio between the two quantities is constant. So when quantities are directly proportional, it means as one quantity increases, the other one increases, or as the one quantity decreases, the other one decreases. Okay, and then we basically say that the ratio between those two quantities would actually be constant. Ratio means fraction. So that's why we say x over 7 kg is equal to 24 over 3 kg, because our ratio is constant. Then all we do, because we have the x and the left on the top, we simply cross multiply the 24 times the 7, divide by the 3 kg. We are left with the x variable on the left. We get 24 times 7 divided by 3, which is 56 rand. They asked us, how much will 7 kg cost? It costs 56 rand. Okay. Then let's look at this one. Zahida travels for 6 hours partly by car at 100 kilometers per hour and partly by air at 300 kilometers per hour. If she traveled a total distance of 1,200 kilometers, how long did he travel by air? Zahida travels for 6 hours partly by car at 100 kilometers per hour and partly by air at 300 kilometers per hour. Okay. What would I do if x was on the right? Guys, x was basically at the bottom on the right. So what I did is I basically took cost, I put it up, and I took potatoes and I put it down. And all I did is I basically, when I swapped it, I then made sure that the x is this side on the left, on the top, so that I would still say cost over 7 kg. You see, cost over the 7 kg still relevant. What was next to x? What was next to x was 24. It's still 24. What was next to x was 24. What is next to x is still 24. What was next to 7 kg was 3 kg. What is next to 7 kg is still 3 kg. You see, but this is just to set up my thing so that I make sure that I actually am able to cross multiply. That's why I usually insist on x being at the left on the top so that I can easily cross multiply. Okay. Zahida travels for 6 hours partly by car at 100 kilometers per hour and partly by air at 300 kilometers. If she traveled a total distance of 1,200 kilometers, how long did he travel by air? So let's check this out. I want to check this. Zahida travels for how many hours? 6 hours. By what? By car. What is the speed? 100 kilometers per hour. And partly by air at what? 300 kilometers per hour. She traveled a total distance of 1,200 kilometers. How long did he travel by air? How long? So this is by car, this is by air. Okay, so now I'll do that one shortly after I'm done with this one. Okay. So again, Zahida traveled 6 hours partly by car at 100 kilometers per hour and partly by air at 300 kilometers per hour. If she traveled a total distance of 1,200 kilometers, how long did he travel by air? that's a $1 million question. Okay, so do we all sort of like have a feeling or understand what this question or what this statement says? Zahida travels for 6 hours partly by car at 100 kilometers per hour and partly by air at 300 kilometers per hour. Okay. Then it says if you travel the total distance of 1,200 kilometers, how long did he travel by air? How long? So that means we don't know how long he traveled by air. What we do know is that Uzahida definitely traveled a total distance of 1,200 kilometers per hour, and the speed that Zahida traveled in, if you combined car and air, is that amount. Okay, so let's do this. Since we have the distance by car and the hours that he took by car, let's find out what the distance was by what? By car. So I hope you understand. So we are going to say, let's remember, we have DST. We are going to calculate the distance by car. Let's look at just the distance by car. Let's start there. So for the distance by car, we have the speed, it was 100 kilometers per hour. We have the time. Yes, I'll put it up on YouTube. The time, which is 6 hours. I understand that some of you need to go to sleep. You are past your bedtime. Then the D, which is the distance, which is what we want. So we are going to say distance is equal to speed times time, which means that we are going to have the distance. The speed is 100 kilometers per hour. We times it by 6. So we get an answer of 600 kilometers. That is traveled by car. So the journey by car was a total of 600 kilometers. Do you see that? All right. There's a reason why I actually drew this out, because I wanted to see what I have and what I don't have. So if I have 600 kilometers covered by distance by this particular car, all right, then and I know that the total distance by car and by air together is 1,200 kilometers. That stands to say that I can now tell what the distance is by air. If it was 600 kilometers by car, then it means it was also 600 kilometers by air, because 1,200 minus 600 gives me 600 kilometers by air. But what do I want now? How long did he travel by air? I have the distance by air, I have the speed by air, so now I can calculate the how long, the time. Okay, so let's go and calculate the time. Okay, so what I've just done after that, therefore the distance in air is 1,200 kilometers minus 600 kilometers, which gives me 600 kilometers in air. That's after calculating the distance by car. Then I can find out the distance by air by taking the total distance of those 1,200 minus the 600 kilometers, which is the distance by car, and I get the 600 kilometers in air. Now I can go ahead and find out this value of x, which is what? It is the time. It is how long it will travel by air. I know the speed in air, which is 300 kilometers per hour. I know the distance in air, which is 600 200 kilometers, and I now have to find the time. Okay, so that means t. My dst, if I want the formula for t, it means t is equal to d over s. Thank you, S1. T is equal to d over s. Let's substitute. 600 kilometers divided by s is 300 kilometers per hour. So the time, what's 600 divided by 300? It is 2 hours. Done. Okay, and that's a meal of marks that you are supposed to get for actually showing your steps for this calculation. Okay, right, yeah, there we go, S1. There we go. Now let's see, S1, I want to backtrack to your question, because you asked a question and you typed it out. Okay, and I'm going to try and pin your question so that, okay, Esona asked this question, and I want you guys to check this out. He said, please do this. If 6 men can dig a pitch in 2 hours, how many men would be required to dig in 3 hours? And that was Esona's question. Okay, and Esona asked this question smack bang. Okay, you were a little bit lost, but you now understand. Okay, please do ask if there's something you don't understand, meaning, eh? Okay, so if 6 men can dig a pitch in 2 hours, now, once again, we have a proportion question. 6 men can dig a pitch, so you have talking about 6 men digging a pitch and the number of hours it takes them. And now we are being asked how many men would be required to dig in 3 hours. Okay, so we're going to write men at the top and write hours at the bottom. Okay, we're deliberately writing men at the top because we are being asked how many men would be required. So we know that we want to now deliberately have our x at the top, what we are looking for. How many men would be required to dig in what? In 3 hours. Okay, so we're deliberately making it a point that we have x at the top, 3 hours at the bottom. I think even in any other question, we can always ensure that we write that particular quantity that we are looking for at the top. And then we know this was required. How many men would be required to dig in 3 hours? So how many men in 3 hours? But in the statement it said if 6 men can dig, 6 men can dig a pitch in what? In 2 hours. How many men then would be required to dig in 3 hours? So once again, before you even answer, the setup of the table is fine. We just need to ask this question. If 6 men take 2 hours, you see, this is a big quantity of people. 6 men take 2 hours. What are we expecting if these men take 3 hours? Are we expecting that more men than 6 will be taking 3 hours, or less men than 6 will be taking 3 hours? Maybe you guys can let me know in the comment section. If 6 men are taking 2 hours, we have a lot of people doing a work, then it takes them this amount of time. Are you expecting more men than 6 to be taking 3 hours, or is it less men that will take 3 hours? So S1 is saying less men. And I'm hoping, guys, we can see that obviously this would mean we are going to be decreasing in the amount of men. From here to there, we are decreasing. If people are taking 3 hours, then it means there's less people taking 3 hours. Because if there were more people than 6, they will take less time. But obviously, okay, if 6 men are taking 2 hours, you are expecting that it will be less men that will take 3 hours, not more. So there's a decrease here. But look at the hours. The hours, there's a increase from left to right. So this is a decrease, this is an increase. What kind of proportion is this? This is indirect. Indirect what? Proportion. What is the definition of indirect proportion says? It says if, or inverse proportion, very true. Inverse and indirect are the same thing. Indirect or inverse proportion. Inverse proportion says if two quantities are indirectly or inversely proportional, as one quantity increases, the other one decreases. Or as one quantity decreases, the other one increases. Now, what do we know? We are also told that the product between the quantities, the product between the quantities, the product between the quantities, men and hours, this is between two quantities. The product between the two quantities remains constant. Product remains constant. For what? For indirect proportion. Product remains constant, not ratio. Because ratio only applies for direct proportion. But since it's indirect or inverse proportion, we know that the product between the two quantities remains constant. Okay? Because what are we expecting? We're expecting less men than 6 to be digging for 3 hours. It can't be more men. Right? So 3 times x is 3x, 6 times 12, 6 times 2 is 12. We divide both sides by 3. X is equal to 4. 4 ndoni? 4 men. Are you shocked? Are you shocked? Do we get it? Are we registering? For inverse proportion, we're not talking about the ratio being constant. We are talking about the product between the two quantities remaining constant. So if you are a grade 9 learner and you are not getting this, then my question is, what have you been learning at school? Okay, my good people. All right. Because like I said, you need to apply logic here when you get to the table. 6 men are digging a pitch. Okay, 6. It takes them 2 hours. Obviously, this is a number of people. If you have men taking 3 hours, this is more hours than 2. Okay, could it be that there's more men than 6 that are taking 3 hours? It doesn't make sense that you would have more men taking 3 hours. It has to be less than 6 hours. 6 men, sorry. It has to be less than 6 people who are digging for them to take more hours. All right? Yeah. So that's why here we are expecting a decrease, because less men, we are expecting less men here. But then here, this is already an increase in hours. So an increase in hours versus a decrease in men. This is called indirect proportion, because the definition of inverse proportion is that as one quantity decreases, the other one increases. Okay? So yes, very true, Mini. What are we expecting? You can see the people that were here when I was starting with the live lessons. People that were here during the holidays. Because I covered this extensively during the holidays. I did a full-on lesson, and I even posted on my YouTube channel. I posted the link in my YouTube channel. Okay? Alright? So hopefully we get this, guys. So x times 3 is equal to 3x. 6 times 2 is equal to 12. You then divide both sides by the coefficient of x. You get x is equal to 4 men. Okay, so hopefully you are answered my amazing person. Okay, that basically asked the question here. Let's move on. Financial maths. Hey, dealing with the finances. Ooh. Dealing with the finances. Okay, dealing with the finances. Peter invests 20,000 in an account paying 15% per annum, compounded annually. Calculate the future value of his investment after 10 years. Again, Peter invests 20,000 Rand in an account paying 15% per annum, compounded annually. Calculate the future value of his investment after 10 years. So, couple of things. Peter invests 20,000 Rand, compounded annually. So there is a formula that we know is involved when we are dealing with a compound interest investment. A is equal to P brackets 1 plus I close brackets to the power n. Okay. Now we are going to go back and read and identify A, P, I, and N and all of these other things that we are being asked. Peter invests 20,000 Rand. What is this, guys? Is this an A value, meaning is this an accumulated value, a future value? P, is it an initial value or a present value or a principal amount, the amount invested at the beginning or borrowed at the beginning? Is it P? Is it I, the interest rate as a decimal? Is it N, the number of years? So this 20,000 that's invested, what is this? A, P, I, or N? What is it? This is, I'm waiting for you to tell me, this is 20,000 Rand is P, the present value, the principal amount. Okay, the amount invested. So 20,000 Rand in an account paying 15% per annum. What is this? That is R, the interest rate as a percentage. But what we want to do with R is we want to convert it to I, which is the interest rate as a decimal number. So we are going to do something special to that R in order to get it to be I, the interest rate as a decimal number. Per annum, compounded annually. This helps us to know which formula we need to use. The A is equal to P brackets 1 plus I to the power N applies only to compounded or compound interest. Calculate the future value of his investment after 10 years. What is this? N. Okay. So A is equal to, I don't know yet. P is equal to 20,000 Rand. I is equal to the 15%. I'm going to divide by 100, which gives me 0.15. And then N is equal to 10 years. So write down and identify A, P, I, and N. Pain. P-A-I-N. Pain. Identify all of these. All right. Convert the interest rate as a percentage from percentage to a decimal number. Then you can go to your formula, write down the formula of the compound interest. Then substitute 20,000 Rand, 1 plus I is 0.15, N is 10 years. You grab your calculator. You just put in everything that you've just written down. 20,000 Rand, brackets, 1 plus 0.15, close the brackets to the power what? To the power 10. Equal. There it is. 80,911. Now, the instruction in the front usually says round off all answers to 2 decimal places. 80,911, 15, because this 4 says to the 5 stay the same. So we know that the answer is 80,000, don't forget the rands, 911,15. Okay, I'm just wondering, what do you mean, is it okay to not include brackets? You mean around all these things that you are substituting? Yes, Okay, that's okay. Because P is a single solitary value outside the bracket, so that's fine. 1 plus I is a single solitary value, a single term after the first term, so that's fine. And then to the power 10 is also just singly raised alone there. Okay, so that's fine. And then please, you punch things right in your calculator, you should get the right value, 80,911 rand 15 cents. Okay. I hope you guys are understanding there. All right. Yeah. I hope you are understanding, and you're understanding very well. Okay. Now, obviously, for your financial maths, there's also there's other things that this paper does not include, like simple interest, a hire purchase agreement, VAT, your VAT discount, where the N amount is in the brackets. Or where the N amount is in brackets, meaning when you are using the simple interest. If it was a different question and it had said an account paying 15% per annum simple interest, then obviously you'd use that formula, A is equal to P1 plus I times N. Then of course you'd put brackets. No, of course you'd put brackets because the I and the N, they are basically combined. So you just put brackets so that you can be able to, know that they have a relationship of multiplication. Okay. Calculate without using a calculator. Guys, surely this should be really straightforward. Minus 6 plus 4 minus 23. This should really be straightforward. Minus 6 minus 23 is minus 29. Minus 29 plus 4. Minus 29 plus 4. So maybe they can, just so that you can give them that satisfaction. Negative 6 plus 4 is negative 2. Negative 2 minus 23, that's negative 25. And you just leave it like that. Nothing really special. That should just be marks for showing steps. Okay, because remember, this thing of saying without using a calculator does not necessarily mean you cannot use a calculator, but it's just that you show your steps, okay, so that you can be given marks. Okay, Kungawe, what's the question for this? Peter invests 20,000 rand in an account paying 15% per annum compounded annually. Calculate the future value of his investment after 10 years. We want the future value of his investment, the accumulated amount, the amount after a number of years is what we are talking about here. Okay, so then what you need is the compound interest formula, because it says compounded annually. That is your clue that you use the compound interest formula. It says compounded annually. A is equal to P into brackets 1 plus I, close brackets, to the power N. A is what you are looking for, the number, the amount after 10 years. P, your principal amount, the amount invested at the beginning. That's P. I, your interest rate, not as a percentage but as a decimal. That's why you take 15%, you divide it by 100, you get 0.15, because I is an interest rate as a decimal number, not as a percentage. Then N, 10 years. A stands for the amount after a few years have passed. It's a future value. The future value, that's what A stands for. It's the accumulated amount. A stands for accumulated amount, the amount that you get after a number of years have passed. But P is the amount that you invest in the beginning of the investment period. Or it could be the amount in a loan situation. P is the amount that you borrowed at the beginning. So these are two different things. Okay, A is the amount after some years have passed. It's the accumulated amount. It's the future value that you are supposed to get. That's what A is, whereas P is the present value, the invested amount, the amount at the beginning. Okay, yeah, so you just need to, in your head, you need to know the difference between A and P. That's what will facilitate you being able to write and substitute the values in the right place. Substitute, and of course we get, it says calculate the future value of his investment. Future value has everything to do with, we want the A value. So we got 80,911,15. This is the amount that basically Peter, after investing 20,000, after the 10 years have passed, this is the amount that he sees in his account. So from the 20,000 that he had, he obviously then gets to see that it's grown, and the total amount that he now has is 80,911,15. Okay. Hope that answers that question. Right, now you can give me permission to move on, because where integers are concerned, I need to remember board mass. I have 11 minus, there's a bracket, and there's a small aniana bracket. So inside, if there's a bracket, small aniana bracket, negative times a negative, that's positive 1. Okay, that removes that small aniana bracket. Now we have minus 3 plus 2, which is negative 1. Negative 1 plus 1, that gives you 0. Now we have 11 minus times 0 gives me minus 0. 11 minus 0 is actually equal to 11. That's basically our answer. Okay. Yes, this is grade 9's Buddha or sharp. Bed mess. Okay. Brackets. Inside the bracket, inside the big bracket, there was a small bracket, so I resolved the sign. Negative times the negative is positive 1. You will find that maybe there was a mark there. That's why you have 3 marks. Then you add, then your final answer. You see? So if you don't show the steps, then you can lose out on some marks unnecessarily. Okay? So please, guys, let's show steps so that the marks can all be ours. We can't afford to be losing marks unnecessarily. 4 times negative 28. Who said we cannot use a calculator? So me, I'm just gonna say 4 times negative 28. It's negative 112. All they want to do, positive times a negative, I know is negative, and that's 112. Done, finished. Move on here. So this is a root. We have a big root, that's a root for everything, but we cannot apply the big root until we resolve the small roots for the respective numbers. So let's go and actually evaluate what we have inside. The square root of 36 minus the square root of 4. So big root stays. What's the square root of 36? Square root of 36 is 6 minus the square root of 4, that is 2. Okay, what's 6 minus 2? That is 4. What is the square root of 4? That is 2. Marks in the bag. I mean, how easy, guys, can we, these people are just like giving away marks to us. They love us, right? Square root of 36, that's 6. Square root of 4, that's 2. 6 minus 2 is 4. Still under the square root of 4 is 2. Okay. Exponents. Exponents. Okay. X to the power 4 times x to the power 7. We're multiplying. Bases are the same. So when we're multiplying same bases, guys, what do? Yeah, I'm sure you can see what we do. Keep the base, add the exponents. So x to the power, that's 4 plus 7, which is x to the power 11. So even if you went ahead and wrote x to the power 11, that will be our answer. So, and I hope my paper looks like this tomorrow. Oh man, that would be funny if it is. Yeah. If it is, then that would be nice. It would be a very cute paper, right? As one. 4x to the power 0. Everything is raised to the power 0. This is equal to 1. Because no one escapes that's inside the house. With the minute that 0 exponent is outside the entire bracket, okay, you can apply the exponent 0 to everything. That's 1. Okay, remember, any base raised to the power 0 is equal to 1, especially if everything is situated inside and the exponent 0 is outside and everything is inside. Then the answer here is positive 1. Look at this question. If you look at the numerator, the relationship that exists here, 3a to the power negative 2b times 24b to the power negative 1 times a to the power negative 1. Relationship at the top is multiply. At the denominator, we have 9a to the power negative 4b to the power negative 3. Okay, so let's look at the numerator and multiply the numerator. So if we look at the numerator, relationship that exists between the bases multiply. So we are going to multiply using S and L. So this is me looking at the numerator, but I'm going to multiply and I'm going to use S and L. In other words, I'm going to multiply the signs first. Positive times a positive is positive. Multiply the numbers next. 24 times 3. 24 times 3, guys, is equal to 72. 72. Then I move on to the letters. A to the power negative 2 times a to the power negative 1. That's a to the power negative 2 minus 1. Because remember, this is like a to the power negative 2 plus negative 1. But plus negative 1, I already know in my head, plus negative 1 will give me a negative in between. Hence, I had written negative alone. But I'm just going to write plus negative 1 so that you guys can appreciate the steps. B, this is b to the power 1 plus negative 1. Okay, just want you guys to see that. But you know, b plus negative 1, that just means 1 minus 1. Over 9a to the power negative 4b to the power negative 3. Let's complete this. 72a, I know this is negative 2, negative 1, which is negative 3. b to the power 1 minus 1, that gives me 0, over 9a to the power negative 4b to the power negative 3. Now that we are done with multiplication using S and L in the numerator, and in the denominator, that just simply stays because we have nothing that we can really multiply. Now we can move on to the next step. After multiplication, we look at 72a to the power negative 3b to the power 0 divided by 9a to the power negative 4b to the power negative 3. So this is division again. So now we are going to divide, but we are still going to use S and L because the relationship between the denominator is just division. There's no addition or subtraction sign. So let's go ahead, divide using S and L. Divide the signs first. Positive times a positive is positive. We are done with the sign. Look at the number now. 72 divided by 9. Surely, even if you use your calculator, 72 divided by 9 gives you 8. A to the power negative 3 divided by a to the power negative 4. That means a to the power negative 3 minus 4. What about b? B to the power 0 minus 3. Okay, hopefully you guys are following. Then I'm going to make sure I take care of the sign there. That gives me 8a to the power negative 3 plus 4. B to the power 0 plus 3. This means 8a to the power negative 3 plus 4 is 8a to the power 1, b to the power 3. That's 3. That's done. Finished. Finished. That mark allocation is mine. 8a to the power 1b to the power 3. But you know the one exponent, you can basically omit writing it, or you can write it. At the end of the day, it makes no difference. It's 8ab to the power 3. Guys, there's something beautiful about this. Once your relationship between the bases is simply multiply and divide, what's beautiful is that if in the numerator there are things that you can take care of, then take care of them. Multiply using sign, number, letter. Multiply and get what you should have in the numerator. Look at the denominator. This was 9a to the power negative 4b to the power negative 3. Then all you do, guys, is you divide. After you are done with the having a single term, the numerator, you divide still using SNL. Positive divided by positive, 72 divided by 9, a to the power negative 3. Remember, this is minus 3, minus. So it changes to plus. So it's like you're saying minus 3 plus 4, which gives you 1. Here you have 0 minus 3. It's like saying 0 plus 3, which gives you 3. So that's why the answer is 8a b to the power 3. Okay. Wow, little Victor, that's pretty good. The L stands for letter. It's like your alphabets. Letter. So this S and L, it's like your variable, basically. I'm sure you guys usually see S and L when you are watching movies that you shouldn't be watching. You know, around about this time, those kinds of movies, S and L, they usually play. Don't watch them, guys. That, you know, when you see S and L, or you see any of these letters on the TV screen, whether you're watching something online or you're watching something that's on the TV, maybe it's a good time to go and do your maths so that you can use S and L and be able to apply it appropriately so that you can get the marks. Look at this one. 2 to the power n plus 2 over 2 to the power n minus 1. Ooh, this one looks nice. The bases, base 2 at the top, base 2 at the bottom. So what do we know? If we are dividing same bases, we keep the base. We then subtract the exponents. Now be very careful. This is a binomial exponent. So when we say minus, remember we say minus, then we put in brackets n minus 1. Now it's time to distribute the negative. That gives us negative n plus 1. Add the like terms. 2 to the power, what's n minus n? Gives us 0. What's 2 plus 1? Gives us 3. What's 0 plus 3? That gives us 2 to the power 3. What's 2 to the power 3? Okay. Guys. Man. This maths. Man. Guys. Maths is weak. Grade 9. I don't care what you say. It's too weak. It's too weak. And those people that see how weak it is, they will get the marks that are sweet this year. They will kill the maths. They will kill it. Okay, nothing will be difficult enough. Okay, what do you want me to explain again? Do what again? This, you want me to do this again? You mean this specifically? Okay, 2 to the power n plus 2. At the denominator, you have 2 to the power n minus 1. This line stands for divide. This n plus 2 is an exponent. This n minus 1 is also an exponent. Okay. So what did I say? Bases are the same. We are dividing. What do we know about division? When we are dividing same bases, we do what? We keep the base n plus 2. Since this is in the denominator, some people usually just do this. They know that they simply change n to negative n. They change minus 1 to positive 1. Okay. This law of exponents is the one that says if you are dividing same bases, you keep the base 2 is the same. You then subtract the exponents. Okay, hence in the other, when I did it the first time, what did I say? I said 2 to the power n plus 2, meaning you're going to subtract this exponent, subtract n minus 1. What does that mean? You subtract n minus 1. We distribute the negative sign. This is 2 to the power n plus 2 minus n. Now, if you have a question, you need to ask it if there's something you're really not understanding about what I just did. If you're really not understanding what I said, what I'm doing, then you add like terms. N minus n is 0, 2 plus 1 is 3. That's 8. N minus n is 0, 2 plus 1 is 3. So that means 2 to the power 3. 2 to the power 3 means 2 times 2 times 2, which means the answer is 8. Okay. I don't know if people still are lost here. Okay. Yeah. This one seems sorted. Hopefully you guys have done exponential equations as well. 4 to the power x is equal to 2. Is it a must to always subtract in this method? What would you like to do? Remember, guys, that like I said, when you are dividing same bases, you keep the base, you subtract the exponents. So what I'm saying is that n plus 2 as the exponent there. Okay, you can also look at it in this way. If you are taking the exponent to the numerator because of the base, this n, the minute this base changes position and goes to the numerator, then the exponents will also change. This means this n, which was positive, will now be negative. This negative 1 that was positive in the denominator will now be positive in the numerator. Okay, but it's the same thing as saying minus n minus 1, because you still get the negative n plus the 1. It's pretty much the same thing. So choose the better approach for yourself. Okay. Exponential equations, that's another thing you need to know. Remember, exponential equations operate under the premise of if you can get same bases on either side of the equal sign, then we know that we can drop the base and equate the exponents. The exponents there are x and y. But because the bases are the same, you simply drop those bases and you equate the exponents. So our answer would be x is equal to y. Now, with these problems, you are always seeking to convert the bases so that they are the same. Okay, I'm really getting sleepy right now, and I have to go to bed soon. 4 can be written as 2 to the power 2. Okay, you can just use your calculator. You just say 4 is equal to shift fact, you'll get the 2 to the power 2. The x is outside, the 2 is already on the other side. We are close. 2 times x is 2 to the power 2x. And what I'm using here is another law of exponents. When an base is raised to a certain exponent and outside the bracket there's another exponent, you simply multiply the exponents. So 2 times x gives me 2x, which is equal to 2. Now that the bases are the same, according to this property, if the bases are the same, I drop the base, I equate the exponent. So that means 2x is equal to 2. Because I just dropped these base 2. And then, I equate the exponents. The exponent there is 1, so it's 2x is equal to 1. My bad, I said 2x is equal to 2, which is not true. 2x is equal to 1, because the exponent for this 2 is 1. Bases are the same. You drop the base, you equate the exponents. We are dropping these guys, they fall away, and we equate the exponents. Okay? Alright? The reason why I'm not writing with a pen is because I don't have one. And I know, because this pen has ended. Like, I actually had a pen, but I was writing with it, and then it just simply stopped working. The only thing I have available with me is a pen. So sorry. Divide both sides by 2. Yes, number 7, yes. So x is equal to a half. Okay. 2x is equal to 1. You divide by the coefficient of x. Yeah, I'm also feeling sleepy. Okay, I'm feeling very sleepy. So I'm gonna, after this one, guys, I'm going to have to scoot. I'm gonna actually do the last question here, which is on number patterns, and then unfortunately I'm going to have to leave because I have an early morning tomorrow. I'm teaching grade 12s early morning, so if I don't sleep, I know I will not make it. I have a YouTube channel, guys. All the live sessions that I cover here, I upload the sessions there on the YouTube channel. So please do go to my bio. The link is there on the bio. You just go and subscribe onto the YouTube channel, and then you guys can go to my grade 9 playlist that I have actually composed of all the live lessons that I've done previously, and you can check those out, and you can actually check those out and help yourself out with that. Sadie Melrose, unfortunately I'm going to have to, because like I said, I have an early morning tomorrow. If I don't sleep, I'm not going to wake up, and then other people are going to be mad because there's those who are waiting for a grade 12 lesson tomorrow morning. Yes. Okay. Right, let's look at this one. Consider the pattern 5, 7, 9, 11. It says write down the next 2 terms of the pattern. Okay. Can someone tell me what are the next 2 terms of this pattern? 5, 7, 9, 11. What follows? What are the next 2 terms? Anyone? Grade 12, 5 a.m. 5 a.m. tomorrow morning. Good. 13, 15. Okay, those who said 13, 15, it seems like you saw the pattern. 5, 7, 9, 11. You found the pattern. Next question. No, they just want the next 2. Please, guys, answer the question whenever they say in the next 2 terms. They're also wanting to check if you can comprehend what they're asking. So if you go on and add more terms, that means you're not answering the question specifically. So you just write down the next 2 terms. Don't write the next 3 and the next 4. You're wasting time, and you are basically not answering the question specifically. If I come to you and I ask you what your name is, and you go ahead and you tell me your name, you tell me where you come from, you tell me what shoe size you wear, you tell me your favorite hobbies, and all of those other things, you are literally giving me information that I didn't ask for. So please be specific, answer the question, get it over and done with, move on. 7.1.2. Write down the general term of the given sequence in the form Tn is equal to. Okay. So at this stage, if they're asking you for the nth term, Tn, the name of my YouTube channel is called Maths is a Game 5 to 7. It's basically the same name that I have for the TikTok channel. Maths is a Game 5 to 7. But what's easy is you just go to my bio, man. Go to my bio. Go to the homepage. Go to the bio. There's a link for the YouTube channel. You just click on the link for the YouTube channel. It will send you directly to it. Subscribe, and then you can go to my grade 9 playlist and check out the videos that I've done with the live sessions. If you want to stay up and basically watch what I've done previously, you can please do that. If not, you can go to sleep after I basically put down this so that you can get adequate rest. You need the rest as well so that you can wake up refreshed tomorrow. Write down the general term of the given sequence in the form. Okay, do we know how we go about finding the general term of the given sequence? Okay, This is a linear pattern, by the way. Why? Because there's a constant difference. 7 minus 5 gives you 2, 9 minus 7 gives you 2, 11 minus 9 gives you 2. So there's a constant difference. Okay, d is equal to 2, t2 minus t1, meaning 7 minus 5. That gives us 2. Okay, so we can say tn is equal to 2n, but that doesn't end there. 2n. The thing is, for a linear sequence, tn is equal to bn plus c. That's what tn is. Tn is equal to bn plus c. This b stands for constant difference. Sometimes they use d instead of b, but the b stands for the constant difference. We found what the constant difference by taking second term minus first term, or taking third term minus the second term. There's a constant difference by which this pattern progresses with, and that is 2. So that b is that value of the constant difference. Hence I said tn is equal to 2n. But I'm missing the c here. Okay? And simply put, if you want to find the c, this is what you do. You can take any of the terms here. Let's say we take term 3. Okay? Which is 9. What's the value of the term? It's 9. What is the position of the term? That's what n stands for. N stands for position. The position of 9 is 3, term 3. Okay, 2 times 3 is 6. Now we want the value of c. You transpose then 6, 9 minus 6, that will give you c, which is equal to 3. So all in all, it's tn is equal to 2n plus 3. Now what's beautiful is you can always verify how true this is. If you substitute t1, the first position, meaning you substitute 1 in the place of n, what's 2 times 1? It's 2. Plus 3, do you get 5? Yes, we do. With your answer, if you substitute 1 with the answer that you wrote down, 2 times 1 gives you 2, plus that number that you wrote, does it give you 5? So that's where you can see that, oh, my answer is right or my answer is wrong. I mean, you can always check your own answer here. You don't have to wait until your teacher corrects you. You can actually see when the answer is correct or not. Okay, you can take any term, guys, substitute it in the place of tn. So for instance, let's take for instance term 4, which is 11. I could have said 11 is equal to 2n plus c. Remember, 11 stands for which position? Because in the place of n, I need to substitute the position. It's 1, 2, 3, 4. It's position 4. So that means 11 is equal to 2 times 4 plus c. What is 2 times 4? It's 8. You take the 8, you transpose it to the other side. It becomes 11 minus 8. Therefore, c is equal to 3. Okay, so you can take any term and its position and substitute in the place of n and tn. Tn, you are going to substitute the value of the term, whether it's 7, 9, or 11, and then in the place of n, you substitute the position. But you must make sure that the constant difference is already found, so that you can be able to find only c, which will be your only unknown. Okay, 2 times 3 is 6. You transpose the 6, you get 9 minus 6, which is 3. Therefore, c is equal to 3. So the value of c here is 3. There's no question about it. 7.1.3 says determine the 100th term. N stands for position. So if they're saying the 100th term, it says the term that is in the 100th position. So what I do, I say tn, I just write out for me first and foremost the formula. Tn is equal to tn is equal to 2n plus 3. Then in the place of n, I substitute 100. Which means in the place of n, I substitute 100. Where n is, I substitute 100. What's 2 times 100? It's 200 plus 3. Then the answer is 203. Okay. Finished. The end. The Edwendo. All right. Guys, ambushed. Okay. Grade 9s, thank you so much for joining in. You guys actually joined in at the spur of the moment, because remember, I had not planned to have a grade 9 session today. That was not my plan. I just thought, let me come onto the live and just see who's here. When I came on here, there was a particular young lad who usually joins my live lessons, who basically then said to me, "Sir, can you do grade 9? I'm writing tomorrow." I was very touched by his comment. I couldn't help but say, okay, let me hop on to the platform and at least do a grade 9 session, because I haven't done it in a very long time. And it turned out to really be fruitful. A lot of people and a lot of you joined in. I think at some point we had like 220 people that were on the live session at once, which was amazing. I really thoroughly enjoyed seeing those numbers go up like that. We now, as I end the session, have 96 people that are on the call, and there's been those who have been consistently here. Kungawo, Umbaliane, Ulilo Victor, number 7, Palesa, Mrs. Zoo. My goodness, your dedication and your commitment is just on another level. Just mind-blowing. You're an amazing teacher, man. Thank you so much for joining in. Sabrina was here. Sadie Melrose. As sad as you are that I'm leaving Sadie Melrose and you wanted me to stay for longer, I have to sleep. Sorry, my dear. But you can always catch me on another live at some other point. Please go to my YouTube channel, guys, and go and subscribe there. You can check out my grade 9 playlist. I upload these videos as raw as you see them. There's no editing, no nothing. So the lagging, the comments, the in-between chit-chatty, me acknowledging answers, and all of those other things, they are all in there. Love Sang Bedi Yeneng, Lady Smith, Skulk, Oahile, Malibongwe, MRTP Fax, Pretty Baddie. Oh my goodness, we got a Pretty Baddie in the mix. Oh my soul. Sarah Proms, SM Goma, Damien Kutsia Tobega, Renee, Fortunate Violue to Mini, and Aim to Timunye, Menzi, was Nendogozo, Kumalo, Zosikolise, Gladile, Branco, Dweza, B, Letabo, Mamdlane, Villa, Cha, Mafunwa, Mudau, Zoe, we've got Gali, we've got Angie, Majox, Londeka, Katlejo, Buddha V, Lady Girl, Amanda, Nomati. Okay, can't pronounce this one. Lebochile, Demagato, Burnt, Jenny Queen, Nondu, Malum T, Koketo, Mfaka, Banele Shatwayo, Slizost, Ngamsha, Zetugo, Crystal von Royen, Bezi, Mziyanda, Kanyesile Lila, African Stallion, Yo Primrose, Togo, Zintle, Sabelo, User, Mumbogoto, Lesedi, So, Wulelani Ngobo, Asanda, Hazelnut, Comin, NC, Yvonne, Milani, just everyone that has been joining in. Thank you so much. It's been great. You guys have been amazing. Yeah, we'll definitely be having more sessions like this. You can rest assured with that. I know that I've kind of abandoned grade 9 for the longest time. Haven't had a session in a very long time, but we'll keep them coming, man. We'll keep them coming, keep them going, keep them flowing. I think more so towards as we kind of like approach holidays, I will continue to have sessions, guys. Even during this little term holiday you will be having, I'll continue to have sessions, and I'll continue to do what I can do so that we can keep up to speed. Start the syllabus a bit early, even for that what we are going to be doing next term, right? For the grade 9s, and yeah, let's get the maths going. So to the grade 12s, like I said, I'll see you at 5 a.m. tomorrow morning. I'll be doing grade 12 related stuff tomorrow morning at 5 a.m. So see you there. Hopefully I'm able to wake up, but if I don't get 5 a.m. started exactly, it will be anywhere just between after 5 a.m. to 5:30. But I'll try, guys. I try. But thank you so much again. I upload on my YouTube channel. The YouTube channel is called Maths is a Game 5 to 7. You can go to my bio. The link is there. The link to my YouTube channel is in my bio. Maths is a Game 5 to 7. You just go there, click on the link, send you directly to the YouTube channel. Subscribe, please subscribe, please. I need more subscribers. Subscribe, and then definitely more uploads coming up. intending to really get it spiced up, get the content a little bit better, and so it goes, and so on and so on. But I've got everything else that I've been doing there, so you can go onto the YouTube channel. You can go to the grade 12 playlist, grade 11 playlist, to the grade 10 playlist, the grade 9 playlist. You can go onto the main page itself, the home page, the most recent videos that I've posted. Views are very low, but I can tell you this one thing: doesn't mean that the content and the quality of the content, insofar as the explanation of the terms and the concepts, is not as good as you would want it to be. All right. And thank you guys. I appreciate it. Have a good night. Please take care of yourself. Sweetest of all dreams. Those who are writing tomorrow, all the best. The grade 9s especially, because I was attending to you. All the best, guys. You've got this, right? You've got this. Cheers.